Hello everyone. Just gonna do a quick briefing on the storm that's gonna impact the Northeast uh, Friday and into Saturday. So here we go. So notice that we have a trough here, a shortwave trough. This is gonna be our lifting mechanism for the storm, and then we also have kind of like a prefrontal trough, although it's not a front, but it's kind of like a pre. It's like a piece of energy that is going to impact us before the main piece of energy comes through. And I do believe that this uh, piece of vorticity here, this vortmax, may create an intense snow band from southeastern New York through the lower Hudson Valley into northern New Jersey and northeastern Pennsylvania. So let's just pay attention to that. Notice how the trough is oriented northeast to southwest. That's a positive tilt. So that means that the storm is progressive and fast and it's going to go out to sea. But it will strengthen. This storm is all about the moisture because we're going to get warm air advection kicking in, and that's going to bring in the moisture from the ocean. But the column will still remain cold enough at night for the snow to fall. Alright, and another thing is that we're going to be in the left exit region of a jet streak at the time of the storm. So basically, there's a 4-quadrant model for the jet streak, and when you're sorry, it's like this. This is a very long jet streak though, so not ideal for maybe like this. Yeah, that's better. Because it's really extended. But in two areas you have upper level divergence and you have upper level convergence. To get rising motion, you want upper level divergence, because if you have upper level divergence, that means mass is leaving the column, so you get convergence at the surface, and then that convergence at the surface leads to rising air, and that air can cool adiabatically and give clouds and precipitation. And we want that. So that helps form snow and will help develop snow bands in the storm. So this is just the precipitation map for the GFS Friday. You see heavy snow, like I'm predicting that there's going to be a band from that initial piece of energy. And then where it's warmer, there's going to be sleet, freezing rain, and rain. And then at 4 a.m. on Saturday, it's still going to be lingering with the snow in the Northeast here. So it's going to hang around a little bit into Saturday morning. Alright, so then just a little education. Snowfall intensity. The rate at which snow falls is a function of the rate of growth of a single crystal, which peaks around negative 15 degrees Celsius. So there's this zone in the, I would say, middle atmosphere. I could be wrong, but I would say middle atmosphere, where dendrites grow. And what a dendrite is, there are different types of snowflakes, and the dendrite is one of them. And the dendrites grow between negative 12 and negative 17 degrees. And when the dew point is matched up with the temperatures at that interval, then dendrites will grow. and I looked at the soundings for this storm, and the dendritic growth zone is lined up with the dew point line. So we are going to be seeing dendrites. The other way you can increase snowfall intensity is to increase the number of crystals per unit volume. So this sounds counterintuitive, but the way you do this is if you have fragile crystals like dendrites and needles fracturing. So think of it this way. Even though you want a big snowflake, if it fractures, it actually increases the number of flakes in that area. And that's the same thing with ice splintering during riming. And riming is um, when you have supercooled droplets hitting dendrite snowflakes. So that when the supercooled droplets hit the dendrite or any snowflake, really, that can cause some ice to fall off. And fragmentation of larger supercooled drops during freezing can also cause. So basically, anything that's fracturing, splintering, breaking, anything that's getting smaller actually increases what's in that unit volume. And that can make the snowfall more intense. Alright, so forecasting snow to liquid ratio. Warm ground and boundary layer temperatures can keep snow water ratios down. We don't have to worry about that because we have a cold ground right now. A warm layer that approaches zero also keeps ratios down because you're close to freezing. So obviously that will have an impact. You'll get wet snow. Storms having clouds with large amounts of supercooled droplets will not have as high a ratio because riming will occur as storms in which most crystal growth is deposition. Alright, deposition, remember, is gas to solid. So if you have supercooled droplets, that's really no good. Soundings that are almost isothermal with a large portion near zero. So isothermal means almost the same. The temperature goes up into the atmosphere and it doesn't change that much. And they're saying if it stays near zero, then it will have a lower ratio. So that's, again, you would get wet snow. Deep cold air promotes higher ratios, and that's what we are going to have for those of us who are getting snow. Except too cold is no good, but that's not going to be a problem for us. Storm tracks often provide keys to forecasting the ratio. So, storms that go by the water, they produce lower ratios. But we're getting snow at night when it's cold, so we're going to be okay. Areas to the south of where I'm located will not be okay. They will be getting sleet and freezing rain. And yeah, this is from the Hydrometeorological Prediction Center, by the way. So, comments here. I looked at GFS and NAM. The dendritic growth zone is matching with the dew point line, so dendrites will be there. Furthermore, with warm air advection expected to occur, this should add moisture to the storm as air column, even near the coast, will be incredibly cold. With the warm air advection, it is likely riming could occur with the dendrite flakes, and ice splintering during this process could increase the number of ice crystals per unit volume and increase snowfall intensity. For the ratios, I went with 15 to 1 for the coast, only because, again, there might be some rhyming, and I wanted to take everything into account, and 20 to 1 for inland areas. So that means you take your quantified precipitation and then you multiply it by 15 to get your snowfall amount. So if I have 2 inches of snow, I multiply it by 15 to get, wait a minute, sorry. If I have 0.2 inches of rain, then I multiply it by 15 to get the amount, which in my head I don't know. So it's just multiplying your QPF by the ratio here. Here's the warm air advection that I was telling you about. That's going to add moisture. Frontogenesis as well. That's going to help promote snowband formation. And then there's also conditional symmetric instability. It's a kind of instability where the atmosphere is stable in the horizontal and the vertical, but not in the slantwise direction. This usually requires saturation or near it. CSI, as it is referred to, can result in narrow bands of heavy precipitation, particularly mesoscale snowbands. CSI is known to produce mesoscale snowbands. So this is when air parcels rise in a slanted direction at an angle. So this is just the projected snow amounts from the different models. This is the GFS. This is the NAM. And see, the NAM is a lot lower, which is why I was hesitant to go higher at the coast. This is the European model, but the European model is limited because it can only do a 10 to 1. And there's going to be freezing rain in central Pennsylvania, going down into Virginia, Maryland, and the like. I would say there's a chance for about a tenth to a quarter of an inch of isolated amounts up to half an inch. We'll keep an eye on that. So for the summary, winter storm will impact the area Friday into Saturday. So timing, precipitation starts midday for inland areas east of Ohio Valley, and in the evening at the coast, maybe late afternoon. Precipitation ends for inland areas overnight, but snow lingers into Saturday morning at the coast. Okay, so here we go. Impacts. Freezing rain from western Pennsylvania down south along a line to northeastern West Virginia, northern Virginia, Maryland, and Delaware. Baltimore will likely be impacted. Total ice accumulations will range from 1/100th to a quarter of an inch in the worst areas. Sleet over most of northwest and central Pennsylvania, central and southern New Jersey. Snowfall amounts will be reduced to 1 to 4 inches here due to the sleet. Inland, this is where it's really going to be heavy. This is where that band is probably going to be the heaviest. So I'm going to predict that snow very, very heavy at times, especially Friday evening. Total accumulations of 8 to 12 inches with locally higher amounts of up to 14 inches possible in those snow bands. And the coast, I want to go higher, but I can't do that yet. So I'm going to go with a total of 4 to 8 inches with locally higher amounts of up to 10 inches possible in snow bands. There is a moderate chance that these amounts will be upgraded. And here is a map that shows my prediction. So you can see here. I'll leave it up for just a couple more seconds, but this is the map. Okay, thank you everybody for listening. My throat hurts because I had to go through that quick. And happy holiday.